What's up, everyone? Welcome back to Better Biomed. Today we're going to learn about O-rings. And believe it or not, O-rings are pretty important little devices, and you don't always have to order from the OEM because O-rings are one of those things that are generic. They're out on the market. I highly doubt that O-rings are specially made. It's usually an off-the-shelf component, and you just have to know what the materials are and how to measure them. And that's what I'm going to show you today. So the first thing that you should know about O-rings is that they are made out of a couple different materials for medical. There is Viton and there's Buna N, and Viton is often the brown ones that you see here. They're rated for a higher temperature, and also they are used around oxygen pretty heavily because they're non-reactive and they don't oxidize, they don't dry out. Buna N is another common one, often used for sealing surfaces, hydraulics and stuff like that. You can look it up online for your particular application, what material you should know about. The other thing that you should know about is its shore hardness. So a shore hardness is the squishiness of the rubber. Now typical O-rings are going to be shore 70 or shore 75, and the more hard ones are going to be shore 90. So the ones that I'm going to be talking about today are shore 70 to 75, and shore 90 are going to be ones that are used in some hydraulic assemblies and stuff like that. But the ones that we need are going to be squishy. So guys, how do you measure an O-ring? They're actually kind of difficult, and that's because there's three measurements you need to know. And in order to do that, you're probably going to have a set of calipers like the one I have here. So first thing you're going to need to know is the outer diameter. That is the outside measurement of the O-ring. So that would be from here to here. Now remember that you can squish the O-ring, so you got to be very careful. And sometimes your O-rings can be oval shaped, so you have to try and get an O-ring that is a perfect diameter. And I generally take my measurements in millimeters and in inches. So notice I have a wide variety here. I've got 1, 2, 3, 4, 5 different types of O-rings here. They are all different. So the first measurement is your outer diameter. Be careful because your O-ring could be squished, and you can squish it very easily with your caliper. The next measurement is going to be your inner diameter, the ID. The inner diameter is also kind of a difficult measurement to take. So that would be this side of the caliper here. That's going to be your inner diameter. You have to be careful because you can stretch the O-ring out of round, and in doing so, you are going to have an inaccurate measurement. So your ID, your OD, and then there's one other measurement that you're going to need to know whenever you're doing O-rings, and that is your cross section, your CS. Now cross section is going to be this measurement right here. That is actually the thickness of the O-ring. And you can see that this one here and this one here are very similar. However, the cross section on these guys is going to be tiny. You can see the cross section of these two. Those look almost identical. However, notice how this one is thicker. It has a thicker cross section. So that measurement is going to be taken like this, sideways. Okay? So now you have 3 different measurements. Like I said, highly suggest you take those measurements in inches and in millimeters. And you can see right down here how I'm figuring out one of my O-rings that I need to find. So you see I had a measurement of 5.41 millimeters or 0.213 inches. I've got an inner diameter of 0.184 millimeters or 0.07 inches. And I had a cross section of 0.0665 and 0.175. Now mind you, those are rough estimates, okay? Now you can look up online, there's a wide variety of charts that show standard O-ring sizes. And in doing so, you can see that I found this size right here, 004. It's got a cross section of 1.78. You see right here, I measured 1.75 millimeters. That's pretty close. Inner diameter, I have 1.78. You can see on the ID, I had 1.8, 1.84. Again, You have to remember that O-rings can swell and they can shrink. So these are going to be, your measurements are going to be rough estimates. You will not ever measure an O-ring exact, especially if it's been in use. It's going to be squished, okay? I have an outer diameter here of 5.34. You can see over here, my outer diameter, I measured 5.41 millimeters. And I was kind of being generous because I didn't want to squish the O-ring with the calipers, which is very easy to do. So I just wrote down a rough measurement. You can see here, this one here is a perfect match. So once you find the match, what do you do next? Well, you order them. They're going to come in a pack of probably 50 or 100, and that's okay because O-rings are inexpensive. So once you order them, then you have to be very careful at getting your O-rings off. Now, I'm going to do a video on O-ring tools, but if you're out in the field, you don't have O-ring tools, I suggest you make some on the spot. And often O-rings are going to be on components that are softer metals. So if you have softer metals, do not use a stainless steel screwdriver to pry an O-ring off. You're going to scratch the surface and you're going to create a leak and or a spot where the new O-ring is going to get damaged. Non-marring tools, if you don't have any, I use things like these zip ties. You can see I cut this one here at a steep angle, and then I rubbed the sharp angle to get rid of any rough edges and any burrs. And then for the O-rings, you're going to squish them like this. You can see how I got that one lifted. And then you shove your O-ring tool underneath. And that way there you can get under the O-ring to pull it off. There, you can see I got it squished. My O-ring tool underneath. Get it under there. See that? And then you can just pull your O-ring off. That one's actually stretching quite well. Now, O-rings have a tendency of getting harder as they age. So it'll be very common to break an O-ring. That's okay. Try to take your measurements as close as you can, even if the O-ring's defaced, even if it's wore down. Remember, your measurements are going to be a rough estimate, and you're going to use that to compare to a standard size chart. If you have any confusion over what material or what durometer your O-rings are, try to take your O-ring into a place like Granger, and they might be able to measure it and help you out. I can tell that this one right here is not a squishy O-ring. This is going to be a harder durometer, like a Shore 90. This one's a pretty tough little guy. But the one that I just took off is very squishy. It's a 70 or 75. Very, very squishy. So anyway, guys, that is a rough video on O-rings, how to measure them and how to replace them. There's many places for information online for O-rings. Just remember, your application is going to dictate what your material is and the size. Remember that your durometer, while it's not completely necessary to get an exact match, your durometer is going to also dictate your wearability, because a harder shore is going to be a more wear-proof O-ring. So if it's a part that's moving around quite a bit, be aware. If you're working around oxygen, do not lubricate your O-rings with anything other than Krytox. So you're going to put a little bit of Krytox on your O-rings when you reinstall them. They'll be good to go, and that will add for wear-proof. That's because lubricants on around an accelerant like oxygen, it's an oxidizer, it is a fire hazard. So remember, if you're ever around oxygen type components like this guy here, Krytox is the only thing that you can use. There you go, guys. That's O-rings in a nutshell. Good luck, and if you have any questions, leave them down below.